Chapter 21 Chemistry Theory Video 10. So now we can explain paper chromatography using partition coefficients. So now what we need to understand is that there are different partition coefficients of the components that makes up this mixture. So they correspond to the relative solubilities in the two solvents that we use. So when we discuss the 10th example, we saw that the relative solubility of ammonia in water is greater than the organic solvent. In paper chromatography, we have two phases. Mobile phase is the solvent that we choose. The other solvent is going to be the water trapped in the water structure, which is going to be the stationary phase. So then in this figure, we know that we can see the solute molecules are partitioned between the mobile phase and the stationary liquid phase on a solid support. So that gives us an understanding as to what materials are if the faster the rate of movements or as the mobile phase, if the solubility is greater in the mobile phase, the faster would be the rate of the movement as the mobile phase passes over the stationary phase. So it goes up a higher extent, or else the length that it travels is going to be higher. So as a result, the solubility will define how much it is going to travel. If it is more soluble, it travels the furthest. So please do question number 16. If you don't understand anything, please let me know. pH, this is the summary of what we have learned so far in this. pH is the negative logarithm of H plus aqueous ions to the base 10. Then Ka, acid dissociation constant, which is going to be H aqueous A minus divided by HA. Then we compare the acid strengths using pKa values, which is going to be the negative logarithm to the base 10 of the Ka values. Then ionic product is 1 × 10 to the power minus 14 mole square Dm minus 6, which is the multiplication of H plus and OH minus ions. Then a buffer solution doesn't change its pH value when small amounts of weak acid, small amounts of acids or bases are added. So a buffer solution is a mixture of weak acid and its conjugate base, or weak base and its conjugate acid. Then pH of a buffer can be calculated using the equilibrium concentrations of weak acids of these conjugate base and Ka value of the weak acid. Then we discuss solubility product, which shows the equilibrium expression that gives the concentrations of the ions in saturated solution of a sparingly soluble salt. And we took into account the relative number of each ion present. Then common ion effect is something that we discussed. And finally, we discussed the partition coefficient, which is Kpc X solvent A divided by X solvent B concentrations. I hope you understood. If you have any doubts, please ask. And also do the end of chapter questions.